So today we are going to show you something that should allow the community to grow. This is not really a super technical talk at all, but our main goal and the goal in general of Arduino has been, since 12 years ago, to simplify complex processes, because that's all about it. Because engineers, as most of us are, we always try to optimize everything. But for people that get started with something new, it can be extremely complex. So more in general, IoT is very hard. Because I don't think there was already another talk today about being an IoT expert. So maybe no one really is an IoT expert. Everything is new. You still have to learn by yourself every day. All of us has to study really every day. And there is a lot of complexity. The complexity is given by the three main components of the IoT more in general, because there are so many components. I came from a software background, but obviously in the IoT, you have the T. So there are devices, physical hardware. Then there is the software. And then there is your business. And business is neither usually done by hardware or software, but from what you want to achieve with them, so with the data, OK? And the hardware, you can place all those gateways somewhere in the field, and then you have to access them, usually via SSH or some other tricky ways, and have remote connection, and maybe you need a static IP address, IPv4, IPv6, having firewalls in the middle. It's really hard to get started unless you are expert enough to get it done. The same with the nodes. So the entry point for a lot of embedded systems is being really proficient in either C or C++ or similar languages, which is not that easy. I don't know, if you come out of the college, you don't have enough experience to manage them. But you maybe still want to experiment with the IoT. So what you do, we have to simplify. So this is like a piece of brainfuck code. It's a programming languages, obviously. And the software complexity is still high. I was excited by the LoRaWan itself. And then I started, really not that many months ago, but I started reading a bit. And I remember that the whole HTTP 1.0 specification were about 20 pages. I started with LoRa, and there are more than 100 pages. So I got scared. And I say, how can we start? And probably the same feeling are having every new user of the LoRaWan network. So as said, most of us are experts, so we can deal with it. But we want to simplify everything. Why? Because if we simplify for expert, it's going to be extremely fast. And the data. So the data we are going to send every sensor, even out there, they have their own way to specify their data, no? Different formats, hexadecimal, string, whatever it is. It's very hard to have different interpretation of your data. So those are the words of a designer, that people ignores design that ignores people. And the whole idea around Arduino, and probably the reason why it was, and it still is very successful, is that it's not focusing on technology. So probably there is a technology that can be perfect for your use case. And Arduino is good enough to solve a lot of different use cases. Maybe not the best for super vertical applications, but at least doesn't ignore people. So it wants to let the people immediately understand what's going on. And as Massimo said, we want to democratize the IoT. Now it's really, it's a kind of a small circle. How many are we here? Probably 1,000 people. But if you compare that with the whole community of more in general software developers, it's really a fraction of them. we want to make it popular. LoRaWan is so nice that everyone should know about it. And we are not there yet. We are going to work on it. So the first thing that we had, so we had hardware, software, and data. No? I started with some hardware, even the most suggested one. And usually it's, again, hard to get started unless you are an embedded developer. So let's imagine you are a web developer. Playing with an embedded system is super complex. So we started having our own gateway, which is now on sale, by obviously trying to keep it as much compatible as possible with the standards. So the usual something big. We obviously use the microchip 508 crypto chip on top of it. But also a lot of people out there are used to use the Raspberry. So again, try to make something that people already know, they are comfortable with. Don't overcomplicate everything. Just use super standard things. So Samtank, the Raspberry Pi, and the enclosure is nice. The package is simple to understand. And you can assemble by yourself. You don't need super special instruction or screwdriver, extremely small. The same with the node. So the node, again, has a 508 crypto chip. Why? Because even if you get started, you cannot get started without taking care about security. So our idea is to make it simple. That doesn't mean make it stupid. Just simple, so to hide the complexity, but still being professional tools. And obviously, our main effort is also to create useful examples and libraries. When I say professional, also means that really big professional enterprises are putting those devices in real-life tractors. And having the sensors on the brakes, they basically are able to remotely control the tractor in the field for really kilometers and kilometers. And now we go to the software. So the hardware, let's say, is a solved part. Also because Arduino is making open source hardware in the last 12 years. But why exactly Arduino became popular, other than the open source hardware, was the software ecosystem that applies to a lot of partners. So there are really a massive amount of boards out there and cores and architectures that are supported by Arduino. So we tried to create this software that was running basically everywhere and easy to understand again. And especially not just easy to be written, but easy to be read, because a lot of people start learning by reading someone else's code and then cut and paste. Everyone did it at some point of his life. Then obviously, once you are comfortable enough to make your own, you just pick whatever you like and you write your own library. But once you start, you just copy and paste code and read them. So it has to be ready to read. So how can we combine everything? So let's assume I have a gateway. I put that in the field. I have a simple software to program it. But I still have to manage it, to manage updates, to deploy containers on top of it, to do all that kind of things. Do I really need, as a novice user or as a professional, to make SSH tunnels, to know the IP address in advance, to have a dynamic DNS and all that kind of horrible things? No, there is absolutely no need of it. We need a piece of software that is named the Arduino Connector that allows you to remotely manage your gateway. It doesn't really matter even what kind of hardware it is. It can be a Raspberry, an AppSquare, whatever it is, Intel, ARM. It doesn't matter. You install this piece of software, which is open source, and you can control your device remotely by using a web interface. Because a connection is coming from your device directly to our MQTT broker. So let's assume you have this gateway. You want to get started. You go to our website. You enroll it. Go to create.arduino.cc, and you register it. We verify that the crypto chip keys are the original one, and you go ahead. Then how it works. Again, I'm in a web interface. The gateway appears online magically. I click on it, and I have some information. And those are real-time information, so there are no database in the middle. We are not storing your data. But you can see the name of your device, if you have enough space, if there are some containers running. In this case, there is a packet forwarder running that is sending data to the LoRa server. And on the left, you can see you can also deploy containers, change the network information remotely again, or even update and install Debian packages in this case. The next feature is that you can completely remotely deploy containers. And that means enable your gateway to have continuous updates or whatever piece of software you want. Like if you want to update the packet forwarder or to change network server, you just deploy another container or deploy an updated container, and that's it. And you have this panel where you can start and stop whatever you like. The other interesting thing is that you are able to program in Arduino, which is kind of a simplified version of C++, and run your Arduino code on top of Linux, because it runs on x86 and or ARM. So it's just precompiled binary. You put it online. The same applies to the nodes. So you can get started with a Maker GSM, code it online by using our web editor. So you code it. In this case, there is a LoRa example. And as soon as they are nearby a gateway, it's sending data. How is this possible? So what was our main effort? Our main effort was to reuse the power of our community. Because Arduino is a company, but our company is made by our community. And our community built a lot of different compatible libraries. Obviously, one of them, the great part of the community, is the Things network as well. And what they did as first example for their devices was the Arduino device lib, which is an Arduino library. It's compatible with any kind of board compatible with Arduino. The same we did with the NKR1. And then also one of our colleagues, Sandeep, made the Arduino LoRa, which is not about LoRaWan, but more about the underlying protocol, the LoRa protocol. And again, did something in Arduino. So every person can be part of the community, either contributing actively by writing code, or even just by sharing projects, which is the simplest thing that newbies can do. Just copy some code, modify it, create something useful for them, and share them again. Before, we also listened to the Axter team. So they basically do this. So enable people to create new content and share with other people, so they keep learning and keep increasing this growing community. And then there are the data. So the data is that you want to move from, I don't know, hexadecimal to strings. How it works? On a web panel, you click on it and it works. So again, some magic for the user, but something useful for everyone, even for experts. So if I click over there, it happens hello world, OK? If I click again, I get the hexadecimal binary. And I can also download all the data in CSV, because as you know now, the storage is basically free for everyone. So we are going to store all your messages, and you can download them in CSV with timestamps. So now there is a short video that we are going to see. And in less than 3 minutes, this is a real-time setup. So I'm going to set up a new gateway, plug it, give it a name, then click Next. OK, now my gateway is going to be activated by verifying via the crypto chip that is effectively the gateway that I bought. It's going to be activated, and after it's activated, it's also already present in the network server. So we automatically register it to the network server for the user. Now the gateway is online. All done. 2 clicks. Actually, 1 click and a name. Then I can see my gateway, and I can click on it and see everything. So the statistics of my devices. Again, no terminal at all. A nice web interface that I can use on my mobile phone. Then I'm going to do the same for a LoRa device. And again, we are going to create for the user the device UI, app UI, and so forth. The user can put their own values over there and then manage their devices. Because obviously, it's all about having device management, make it simple as possible for users. So here, I can see the new device and my gateway. And from the device, there is the dev UI. I can start writing some code, obviously, and cut and paste everything over there. And again, I'm inside the browser, so I didn't have to download any kind of crazy IDE at all. I'm just cut and paste these values. I have my example. Now I deploy my example on top of my node. It compiles online, so I don't even need a toolchain locally, because it compiles by using our servers. Then you upload everything, as of now, via USB. But with some application, and also from what we have seen before, eventually there is going to be possible to have over-the-air updates of your code, obviously. So now the device is getting online and sending data directly to the gateway. So it's now getting data. Where can I see my data? We created a dashboard for you. So if we go back here, in this case, we have to refresh the page. But this is already being improved in the last few days. And you can see the data directly over there. So again, no terminals, no IDE, nothing super strange. It just works. And it was in real time, like only, oops, something is going wrong here. Yeah. Now, what is the next step? Again, the focus on your data. We are working on a system that is going to be able to use your variables in your code and automatically create dashboard for you. This is going to be released next week in the first version, not supporting yet LoRa, while everything else that you have seen here is already live in production and for free. But we are also going to create automatically dashboard for you. So if you create something, some variable that is named temperature, you can automatically display here, and we create a dashboard for you. This is going to happen next week. As of now, just for a Wi-Fi system, but later on this year, also for LoRa and LoRaWan system. So again, we want to make things simple. And as you've seen, in less than 5 minutes, you start from knowing nothing about LoRa to have a dashboard that is working. Thank you.